Hello classes. Today I want to take a few minutes and review with everybody how to work some problems that have exponent rules. There's two main goals I have. One is just to re-explain the rules for everybody, and two is just to help you understand what order to do things in when you have multiple terms in a problem. So first I'm going to start with reviewing some of the basic rules. The first one is when we are multiplying together. What I'm going to do first is show you by expansion. I'll take the first problem and rewrite it expanded. So I'm going to have 3 times R2 times the x and the other x. And you notice I have rewritten the order here. I've put my number bases first. Remember, when we're multiplying, it doesn't matter what order we're in. So now I've got the 3 and the 2 done. Multiply those together, 6. I have two x's. X times x will be x to the second power. We can just add the terms when we're dealing with variables and exponents, but remember that doesn't apply for the numbers. Those are multiplied normally. For a second problem, we're dividing. If I show you this with expansion, in my numerator I have 4 b's. And in my denominator, 1. I could then cancel, and I'm left with 3 b's in my numerator, b to the third power. To write that in simplest terms, I don't need to write over 1. I'm just leaving that as b to the third power. One of the things I have noticed is some students are still wanting to write over 1. Well, technically that's correct. We can simplify that just by writing it as b to the third power. So I'm going to eliminate that and leave b to the third power. Okay. Next we have power to a power. The thing to remember about power to a power is you're also working with whole numbers sometimes. And when you have a number base, we have to deal with that normally. What I mean is, in this problem, you have a 2, there we go, to the second power. And you also have n to the third power that's being squared as well. To show you that in a cleaner way, 2 to the second power and 3 n's also to the second power. So altogether, they're 6. So for my final simplified answer, 4n to the 6th power. When we get to problems like 4, now we're using all of our rules simultaneously. We have power to a power, we have some division, we have some multiplying. So I typically start working numerator, then denominator, and then I start to simplify and cancel. So I'm going to write a fraction line or a division line, and then do my numerator. I have a u squared to the second power, u to the fourth, and I also have a u to the third. And those can then combine u to the 7th power. For those of you noticing odd things showing up as I'm writing and clicking, this is my first video, bear with me. And I'm just doing best I can with some weird buttons, but I hope I'm informing you at the same time. In my denominator, I have a 2, a v, and a u to the third. There are no like terms to combine. There are no powers of a power. So I can just write out my terms. Now I just have one more step. I can cancel some of the u's. There's 3 in my denominator. There's 7 in my numerator. And when I cancel them out, there'll be 4 left. So to write that in simplest form, u to the 4th over 2 v I'm going to look at a few more problems with you now. These two problems are some examples where I've noticed some struggles in class, and I'm hoping I can clarify that with you now. So I may choose to expand these out a little bit so you understand what is happening. Okay, we have 2 times n to the 6th power multiplied by 2n to the 2nd power raised to the power of 3. First thing I want to do is deal with this part here. So I'm going to go 2 to the 3rd power, 2 times 2 times 2. And I also have n squared to the 3rd power. 2, 2, 2. Now along with that, I also have this 2 and 6 more n's. That's a lot of n's, and I'm being really messy with that. I'm going to recombine that. I'm going to put all my 2's first, and now I'm going to put all of my n's. There's my 6 from here, and now I have these 6. So altogether I have 4 2's, 2, 4, 8, 16, and 12 n's. For our next problem, we have division of both exponents and number bases. A misconception I'm seeing is when we're dividing the whole number bases that some students are getting confused and subtracting. We're going to divide these normally. 16 divided by 2 will be 8. We're not going to do subtracting on the whole numbers. That's only for the exponents. Again, 16 divided by 2, we do that like we always have. That is 8. Now let's move on to the variables. 5x's, 1x. When we start to simplify, 5 minus 1 is 4. Y's. 2 y's here, 2 y's there. They'll both just cancel out and become 1's. Now, some students at this point are writing a 1 in the denominator. While technically you're right, that's not the simplest way we can write it. Since any number over 1 is itself, we're just going to leave this as our final answer, hx to the 4th power. And we don't have to write any fraction or division line, and we don't have to write a 1 in the denominator. Now let's look at a couple more examples where there's many things happening at one time. There we go. All right. We have some combining. We have power to a power. We have some division. My first step on this problem is I'm going to simplify anything that I can first in the numerator and denominator. And if I see any easy canceling I can do, I'll take that chance when I can. And then finally, the third power that everything gets raised to. So one of the things right away I notice is I have these z's here, 3 of them. And I have z to the third here and here. So I can take one of those out. That's a really quick cancel I can do to make life a little easier. If we don't do that, our answer still will work out the same, as long as we do everything right. Next step, combine. We have an x. We have 4 plus 2 y's. And we have 3 z's. All of which to the third power. In our denominator, we have 2 and a y, and that also is being taken to the third power. I'm going to go ahead and bring everything to the third power, and then I'm going to start to cancel where I can. Six times 3 is 18 for the y's. Z's, 3 times 3 is 9. Denominator, 2 to the third power, 8. Y to the third power is y3. And finally, we can simplify 3 y's in our denominator. We'll cancel 3 in our numerator, and that will leave us with 15 y's. So finally, x3, y to the 15th, z to the 9th, and the whole number 8 in our denominator. For the last problem I'm going to look at with you today, we have a few integers now showing up. It's also a misconception I've noticed some of us are dealing with, especially that -1a. Remember, part of simplifying is we tend to not write the ones in algebra. So really this means, if I were to rewrite this or insert a 1 here, -1a, or a -1. So when I start to simplify this problem, again working numerator then denominator, I'm going to take everything here to the 4th power. So -1 to the 4th power is actually just 1. A to the 2nd to the 4th, b to the 3rd to the 4th, 4 times 4, 16, times 2ac. And now before I do any more with any parts of the problem, let's see what we can combine. We have our a's. That gives us a to the 9th. We have b. And we have 2 terms with c's. And we also have the whole number 2. In our denominator, we have a b, c, a to the 3rd. Okay, we're almost finished with this problem and with our video. So let's start canceling. 3a's in our denominator. We'll cancel out 3 of these. One b in the denominator. We'll cancel one of those. 1c in our denominator. We'll cancel with one of those. And now I'm going to just rewrite this in a little more simplified manner and eliminate our fraction line. Again, there's no need to write over 1. That won't change our answer. Okay, I'm hoping this helps you out, and I hope to do some more videos soon to help your learning. And as always, I appreciate you watching, and please come with thousands of questions from me in class. I'll talk to you later.